Hi, this is Abhishek. Welcome to my channel. We have started a new series on problem solving of linear algebra, and these problems are actually important for SET, GATE, IAS and SSC and also in the PSC examinations. So let's start with the first problem. Now the problem that you can see is here. If A is a matrix, B is a 2x2 matrix given, A is a 2x2 identity matrix, and C is a matrix defined as cos theta sin theta minus sin theta cos theta, then which of the following relation is true? Okay, there are four options. There is a multiple choice question, only one answer is true. Let's see which one of the answer is correct. Now you can see all the options are given is either you need to calculate A cos theta, A sin theta, or B sin theta, B cos theta. So first let's start with calculating A cos theta. We will go by option. Okay, first let's calculate A cos theta, okay, which is 1001 into cos theta. Since cos theta is a real number, the multiplication will look like this: cos theta 0 0 cos theta. On the same time, if we calculate B sin theta, it would be 0 1 minus 1 0 into sin theta. Again it would be 0 sin theta minus sin theta 0. Now if we add A cos theta minus B sin theta, it would be, so if we add A cos theta minus B, if we calculate this A cos theta minus B sin theta, which is basically this one, cos theta 0 0 cos theta minus this quantity. Sorry, let's rub this part and calculate the area. Okay, so B sin theta is this value, B sin theta value is this, and A cos theta value is this. Okay, so let's calculate it here. Okay, if we calculate A cos theta and B sin theta, okay, good. Let's calculate it here. So it would be cos theta 0 0 cos theta minus 0 sin theta minus sin theta 0, okay, which will be, again, that would be equals to cos theta sin theta, sorry, minus sin theta, because the minus sign is there, minus of that, plus sin theta and 0. You can see, so the C is, but you can see the C is not equals, but this is not equals to C. Obviously you can see that here in this position, A21 position, there is minus sin theta is there, where we can see this is sin theta. So obviously this is not equals to C. So first option obviously is incorrect. Okay, since it is already, since we already have calculated A cos theta and B sin theta, now let's calculate the option D, which is given. Okay, option D, which is given as A cos theta plus B sin theta. Okay, so A cos theta is this value, cos theta 0 0 cos theta plus 0 this plus this one, 0 sin theta minus sin theta 0, and it would be, you can see, cos theta sin theta minus sin theta and cos theta, and you can check it, this is exactly equals to C. So obviously, so the last option is true. We do not need to check the other two conditions B and C. Okay, so the last option is true. Okay, now let's jump into the second problem, which is given as if 5 1 4 1, this is a matrix, this matrix into x is obviously a matrix because the output is a 2 cross 2 matrix. So here x is a matrix, then x is equals to the following matrix. Okay, let x equals to a matrix like this, x11, x12, sorry, without considering 1 1 1 2, let's consider just x1 x2. Okay, x1 x2 x3 x4, because it's a 2 cross 2 matrix, right? Otherwise this multiplication is not possible. So we have considered a 2 cross 2 matrix. Now let's perform this operation, which is given as 5 4 1 1 times x1 x2 x3 x4. Let's perform this one, which is, that is the LHS. If we calculate the LHS, which would be 5 times x1 plus 4 times x3 and 5 x2 plus 4 x4, x1 plus x3 x2 plus x4. Okay, if we just multiplication, it's a general multiplication between two matrices, and the RHS given as this is. So if we just compare LHS equals to RHS, we'll be getting 5 x1, that is this matrix equals to the matrix given 1 2 1 3. If we compare component wise, then 5x1 plus 4x3 equals to 1, and x1 plus x3 equals to 1. If we just solve this equation, we will be getting, so just multiplying by 5, so 5x1 5x3 and 5, so multiplying by 5, multiplying 5 both side. Okay, so if we just solve this, we'll be getting minus 4x3 equals to minus 4, which actually gives that x3 equals to 1. Okay, we are getting that x3 equals to 1. Similarly, let's rub this one. Okay, again x3 equals to 1, so putting, so 5x1 equals to 1 minus 4x3 from the first equation, and that give rise to 1 minus 4 times 1, that is equals to minus 3. Okay, oh sorry, so I made a mistake here, sorry, I made a mistake, that is, this is not 4x3, this is only minus x3 is 4, so obviously x3 equals to plus 4, so this would be 4, so 1 minus 16, so minus 15 is here, so that is minus 15, right? 1 minus 16 is minus 15, so x1 equals to minus 15 by 5, which is minus 3. Okay, so x1 is minus 3, x3 is 4. Similarly, if you calculate the other equations, then what you will be getting is the following. Okay, if you calculate the other quantities, then you would be getting x2 as, so we already got, let's write down here, we already got x1 equals to -3 and x3 equals to 4, and if you solve these two equations, these equations with and these two equations, you would be getting x2 equals to -10 and x4 equals to 13. Okay, just check that. Okay, now obviously if you just can check that this is exactly matching with the -3, -10, 4, 30. So this is exactly matching with equation 1. So the option 1, sorry. So this is the correct one. Okay, if you check -3, -10, 4, 13. Okay, so this is the option. So this option is correct. Well, let's jump into the third problem, that is, if A is given as 3, 2, 1, 4, we need to calculate A times adjoint A, right? Okay. Now I guess you know the formula for finding adjoint A. Formula of finding adjoint A. Adjoint A is Aij transpose, where Aij is the cofactors. Cofactors, where the definition of Aij gives this way: -1 to the power I plus j. I and j is the row and the column position into its corresponding minor. Let's calculate it. Okay, first let's calculate the cofactor matrix, that is of this matrix. So first let's calculate the cofactor for the 3. So we'll forget about the first row and the first column. So the determinant of the rest is 4. So the cofactor of 3 is 4. What is the cofactor of 2? Cofactor of 2 is, forget about the first row and the second column. Then the cofactor would be -1 to the power I plus j, that is -1 to the power 1 plus 2, because the first row and the second column, into the corresponding minor, which is 1. So -1 to the power 3, this is -1. Okay, so cofactor would be -1 here. Similarly, the cofactor of -1 would be -2, and the cofactor of 4 is 3. You can check it out. Now the adjoint matrix is just the transpose of this matrix. So the adjoint A equals to the transpose of this matrix, which is 4, -2, -1 and 3. We need to multiply A with this matrix. So if we just perform the multiplication, what we would be getting the following. This is A and this is my adjoint A. Okay, I am rubbing this part. Okay, if we want to multiply A with A into adjoint of A, that is exactly equals to, okay, that is exactly equals to 3, 2, 1, 4 times this matrix 4, -2, -1 and 3. Okay, that the matrix would give rise to, if you just calculate the multiplication, 3 into 4, 12, -2, that is 10. Okay, -6 plus 6, that is 0. 4 minus 4, 0. -2 plus 12, that is again 10. So the matrix is exactly equals to 10, 0, 0, 10. So which is the first one? Okay, the first option is true. Let's go to the fourth problem, which is given as A is a 3 cross 3 matrix defined as this. and I is a 3 cross 3 unit matrix, then rank of I minus A. Now first of all, I guess you all know the definition of rank. Rank of a matrix A is defined as the number of linearly independent linearly independent rows or columns, the same thing. Okay, so we know the definitions. If you do not know the definition, please go and read some linear algebra, basic linear algebra books. Almost in every books you will get that definitions. Now let's calculate the matrix I minus A. We know I is a 3 cross 3 unit matrix, that is an identity matrix. Okay, 1 0 0 0 1 0 0 0 1. Okay, minus 5 0 2 0 1 0 minus 4 0 minus 1. If we just calculate this quantity, the matrix will be minus 4 0 minus 2. That's just perform the component wise subtraction. 0 0 0 and 4 0 2. Okay, think about that. Okay, so I minus A, what we got, let's rub this part. I minus A is this matrix. Okay, rub everything. So let's write the matrix again. So I minus A, the matrix we get is minus 4 0 minus 2 0 0 0 4 0 2. I said the definition of rank of a matrix is number of linearly independent rows or columns. First of all, see the 0. This is a 0 column, so it will not contribute anything in finding the rank, because 0 vector is obviously will not go in the linearly independent set. So we are not considering it. So the rank of this matrix is less, either 2 or less than 2. Okay. Now say this is the first column, that is C1, and let's say this is the third column, and let's identify it as C3. You can easily see C1 can be written as 2 times C3. You just multiply with 2 of this third column and you will get back to the first column. So C1 and C3 is linearly dependent, because C1 minus 2C3 is 0. So basically the linear combination of C1 and C3 is 0, but the coefficients are not 0. Okay, so at least, so this coefficient is not 0, this coefficient is 1. So we are getting the coefficient of this C1 and C3 is not 0. So which says that this column vector C1 and C3 is linearly dependent. So only one will contribute. Okay, so the only independent column is, say for an example, C3. So other columns are linearly dependent. So the rank of this matrix is 1. Is this clear? So there are 3 columns. So maximum rank can it be is 3. But first of all, the second column is 0 column, which will not contribute in the rank because 0 vector cannot include in a linearly independent set. Now consider the first and the third column. First column is a linear combination of the third column. So only one column will contribute in the linearly independent set, because C1 and C3 is linearly independent. So rank of this matrix is 1. So correct answer is 1. Okay. Now let's jump into the last problem, which is A equals to a 2 cross 2 non-zero 2 cross 2 matrix where A, B are non-zero real numbers, and AM equals to A to the power 2m is given. Then which of the following is true? Now let's take m equals to z plus, that is from the positive integer set. So for the time being, for case 1, we are taking m equals to 1. That is, we need to calculate, so a would be a square, that is, we need to calculate the a square. Let's calculate a square first. A square is nothing but a into a, so b minus a into b minus a. If you just calculate this, it would be a square plus b square, and this column will be ab minus ba, which is 0. This one ba minus ab, again 0, b square plus a square, so this is again a square plus b square. So we can write down this as a square plus b square, since this is a real number, which is 1001. So for a square is this. So first one, so obviously the first option is not correct, because if we put m equals to 1, it gives rise to a square b square minus a square. So this is not correct. So this option is not correct. A square plus, so if we put 1 here, so a square plus b square into 1001. So this option might be correct. This option might be correct. We need to consider it. A square a plus b. So if we put m equals to 1 here, so it would give rise to a plus b into this. So this option is also not correct. And it is given because a and b are non-zero real numbers. Okay. So, and if we put m equals to 1, this option might be correct. So we are not sure that whether 2 or d, so whether b or d, between b and d, any option might be correct. So to make sure this, we need to calculate a to the power 4. Okay. If we calculate a to the power 4, so it would be a square plus b square times 1001 into a square plus b square times 1001. So, and since this is a real number, we can just give a square here instead of writing this. Okay, and this is an identity matrix, this is an identity matrix. So if we multiply between two identity matrix, I into I, it will be again a. So it's nothing, it's not contributing anything. So ultimately we are getting a square plus b square whole square 1001. So when m equals to 2, we are getting a4 is this. Okay, now put m equals to 2 in this option. So it gives rise to a to the power 4 plus b to the power 4, but we are not getting here. See, here is a square plus b square whole square. So this is not actually equals to a to the power 4 plus b to the power 4, because there are two a square b square terms and the other terms will be there. So this option is not true. So you can see, if m equals to 2, so a square plus b square whole square. So exactly this is true. So option D is correct. Okay, I guess you understand these 5 problems, and if you have any doubts, please let me know in the comment section below. Thank you very much.